Hello everyone, welcome back to our Kotlin tutorial series. In today's video, we are diving into one of the most exciting and essential topics in Kotlin, that is coroutines and concurrency. So, if you have ever wondered how to, manage background tasks, handle, long-running operations, or make your app more responsive, this video is for you. We will explore coroutines. We will discuss the key functions like launch, async, and await. Learn how to use dispatchers effectively. So let's get started. So always remember whenever you are trying to get into asynchronous programming where you are uncertain that okay, you don't want to, it's not uncertain, it's like you don't want to wait for a certain things to get processed sequentially. It's like one will get processed, two will, after that two will get processed. No, what I mean is that the entire process will be started, and we will be certain that every process, that is 1 2 3 4 up to 10, will return something. So for that, we will not wait till 1 to finish and 2 to get started. It's not like that. It will be started concurrently. Okay, so every process will get started and we will get a result at the end, and that will not be blocking to anybody, and that will end. And after the ending of the task, okay, we will aggregate the data and we will show it to the user. Okay, that is how it works. So let's start with the basics, that is launch. Okay, so this is the simplest way to start a coroutine. So what is coroutine? So first of all, you have to understand what is coroutine. So coroutines are basically lightweight threads. Okay, so they allow you to write asynchronous and non-blocking codes. Okay, so unlike traditional threads, coroutines are more efficient as they're managed by the Kotlin runtime, and it can be paused and resumed without blocking the main thread. So let's start with the launch first, and we will see the async and await after that, and we will show how it can be done. So let's go to the IntelliJ, and let's suppose, so whenever you write these things, right? So suppose I write a sample functions. I write a sample uh, coroutine demo function that I'm writing. Okay, and what I can do is I will, so what the basic things is suppose I write thread dot sleep. Okay, and I give it a delay of 1000 milliseconds, and after that I print, sleep ends. Now print your statement. So once the sleep ends, now you will be printing your statement. So I will print, this is my statement. So I will, what I have done, it's very, it's a very common one. Okay, it's a very common one that I have created. It's basically I am trying to check that this thread is sleeping or what. Okay, okay, now we run it. So this is a basic thing that I've written, that it will wait for 1000 milliseconds, and after that, you see, that has been, it will print sleep ends. Now print your statement. So after that, the println will be printed. So this println is basically waiting for, this is a blocking statement, right? It's blocking the main thread. Okay, so suppose you have something in the main thread and you don't want to wait. Okay, so you have your own, you have your own coroutine that will go and execute some of the code, it will not block the main thread. In those cases, what we can do is, in those cases we will write coroutine. So for there to start a coroutine, we have something called launch. Okay, and this function has to be run blocking. Okay, So inside the run blocking, you need to write the launch. Okay. So what this launch will do, suppose I do a delay of 1000 milliseconds and I write println this delay is not stopping the main thread. So what I have written is I have a given a basic you know thread structure here that it is calling the launch, and inside the launch function what happens is it is delaying 1000 milliseconds, and after that it is printing this delay is not stopping the thread and not stopping the main thread. So basically whenever it runs, the main thread will get executed and it will not wait for 1000 milliseconds. So in the main thread what you have is println, like, so whenever you run this, the println will get printed first. It will not wait for that because this is a coroutine. Okay, this is the kind of asynchronous function that we want to implement. As you can see, whenever I run it, so this is my statement that has been printed, and after that, whenever the launch inside the launch function, you have that the delay of 1000 milliseconds. There, it is printing this delay is not stopping the main thread. That's what happened. Okay, so it's simple. So it runs in parallel, and the run blocking ensures that the program doesn't exit before the coroutine completes. Okay, this is very simple. Okay, now let's go to async and await. Okay, so basically it's for returning the results. So what if you need to return a value from coroutine? That's where the async and the await come in. The async builder creates a coroutine that returns a deferred object and which can be awaited till you get the result. So for that, I will check. Okay, I will show you how it can be done. So basically, I will define a deferred well. I'll define a deferred well and I will write async function here, and I will give it a delay of 1000 milliseconds, the same like that, and I will return it hello from async. Okay, and after that I will write the same thing, println waiting for result, and after that this is my statement, or I will that this is my result from async function. In those cases I will write that is deferred dot await. Okay, so this await function, it suspends the coroutine until the result is available. It's so powerful. It's so powerful for concurrency that whenever you're calling this in the main thread, it will wait for the async function. So it will wait that until it is returning a value, right, in the asynchronous function. So until it is the asynchronous functions, uh, you know it is returning a value, it will wait, and after that it will whenever it returns the value, it will print. So that's how the see waiting for the result. This is my result for the async function, and after that hello from async. Okay, so first the main, so you have to understand how this program is working. So first the println waiting for result is being printed because this is the main thread. Okay, and after that this is being also printed that this is the result from the async function. So after till here it will be printed as part of the main thread, and after that it will wait for the async function to return its value. So inside the async function what is happening is it is delaying for 1000 milliseconds and it is returning hello from async. So that is the reason. So if I do it like 200 milliseconds, though, so the you will get a better understanding. So if I run it, you will see that the first two lines will get printed. So first two lines are printed. After it is completed, the await function returns the value and it prints. It's simple. It's that kind of powerful concurrency that you can have. So okay, so we have completed the async, deferred, and so it basically, the deferred is nothing but it's an object which is getting returned by the async function. Okay, so this is pretty much the basics, and after that, now we will be looking at the dispatchers. So what are dispatchers? So here you have the dispatchers, right? So we have discussed this launch, async, and await. Now we will go to dispatchers. So dispatchers determine the thread on which coroutine runs. So it's just like, you the kind of think of it in a Java way, like the kind of thread that you want to take, that the thread dot get current thread name, something like that. So it provides several built-in dispatchers. So suppose you have dispatchers.main. Okay, it used for some of the UI operations in Android, and the IO operations related dispatches are also there. It's like reading and writing files or network request. So some of the you have default dispatches, like it's for CPU intensive operations, and you have unconfined dispatches. Okay, so it start in the current thread, but it's not bound to any specific thread. Okay, so I'll just simply show you how it is done. So what I can do is I will do inside this. What I can do is I'll do a launch function. Okay. So in the launch function, I will uh, the dispatcher, I'll write dispatchers.io, and I'll do what? I'll do a println running on IO dispatcher, and I will give what? The thread dot current thread dot name. Okay, so this will be running on the IO dispatchers. Okay, so every dispatcher has its unique way. Okay, so if, like if you want for a if you want your threads to be run on an IO dispatcher, because it's a reading and writing intensive operations, then you choose the dispatchers.io. If you want a different dispatches, then what you can do is you can write a different dispatches dot default. Okay, I'll write println, and now I'll check what running on uh, default dispatcher. Okay, now I'll print the thread current thread name, thread dot current thread dot name. Okay, now I'll run this. So it's lets you you have to understand this is a so this is the default dispatcher worker one. This is the default dispatcher worker one. So currently it is running on these two. Okay, so based on this, okay, based on these two, so it's just like I'm just showing you the flexibility. It lets you to optimize your you can optimize your app's performance. So if you are choosing the IO dispatcher, then it will be running on the IO dispatcher itself. If you don't if you want a different dispatcher, it will be a different dispatcher. Okay, so the kind of use cases that you are trying to solve, based on that you can use that kind of dispatcher that you want your coroutines to run on. Okay, so to recap, we learned about launch for fire and forget tasks, async and await for returning results, dispatches for controlling coroutine context, coroutines that make Kotlin an incredibly powerful language for building modern and responsive applications. So that's a wrap for this video, and I would suggest you and highly recommend you to practice coroutines. So whenever you are preparing for Kotlin interviews and you're going for different kinds of backend roles, I would highly recommend you to go through these fundamental concepts, because this will be asked in the interviews. So asynchronous programming is the modern trend, where you will be asked different Kotlin concepts or any asynchronous programming in Java. You will be asked for the threads and all. So I highly recommend you to create a project and to understand how the coroutine works. Okay, so that's it for today. That's a wrap. If you find this video helpful, give it a thumbs up, subscribe for more Kotlin tutorials, and let us know in the comments which coroutine feature you would like to learn next. Thanks for watching. See you in the next video. Thank you. Happy coding. Bye.